In the last video, we have introduced trigonometric series, and in this video, we are going to introduce Fourier series. So let's start with a definition. Given a trigonometric series and f which is integrable in the closed interval negative pi to pi, the Fourier series is the one whose coefficients are given by the following manner, and we call these coefficient Fourier coefficient. So you may wonder why I define these coefficients like this. So I will explain this later, and we'll first introduce the basic information that we can obtain from the definition. First of all, as the Fourier coefficient depends on integration, and integration depends on the global information of the function, the Fourier series indeed depends on the global information of the function. The second is that if two functions are differed by the set of measure 0, then their Fourier series should be the same. The reason is that the integral of two functions who are differed by a set of measure 0 should have the same integral over the interval. And in particular, the Fourier series depends on the value of f in the open interval of negative pi to pi, because we can drop the two endpoints, which is a set of measure 0, and we will get the same Fourier series as well. So, what is the motivation of defining the Fourier coefficient like this? Well, if we have a function which is integrable and it is very nice, we should expect that the function should be equal to the trigonometric series itself. Then we multiply both sides by cosine nx, and using these two integration identity, we can obtain our an. And I will leave it as an exercise for you. And it is similar to obtain the bn. But what is different from obtaining an is that instead of multiplying both sides by cosine nx, we multiply both sides by sine nx, and you can define similar integration formula like the former one, and we can obtain bn by multiplying sine to both sides. So this is the end of this video about Fourier series, and we will continue on the other properties of Fourier series in the next video. See you in the next video.